What is telemetry? The definition used in the course for telemetry is a collection of measurements or data at remote or inaccessible points and their automatic transmission to receiving equipment or monitoring. So basically, it's getting data from a system and transmitting it somewhere so that you can monitor that data that you received. So the data collected through telemetry can include various types of information, such as system performance, status, environment configurations, as well as data generated by the system's operations. There are several sources of telemetry which correspond to the three pillars. So you can have logs that are transmitted, metrics, and traces. So we'll go through each of those in some detail. But in summary, logs are essentially texts that indicate some information about an event. This is a type of capability that's been in place, for a long time, certainly right back to the 1980s. I guess I'm old enough to remember that. In fact, even prior to that, we had logs in a data communication system I was working with. An example of a tool was syslog. It's popular, and that tool goes all the way back to 1984. Metrics, so really these are numbers, things that are aggregated or calculated about events, usually aggregated across multiple events. So there's a tool such as Top that's been in a Linux tool for a long time to look up metrics for things like CPU performance. This has been a standard since the 1980s. And there are other tools that have been around quite a long time to help with different kinds of metrics. Nagios is a popular one. It was introduced in 2002, and it's used for things like performance and network monitoring metrics. And more recently, traces as a capability to look across different spans of a distributed system where you've got events interconnected and you're looking for patterns across the interconnected systems for tracing an activity through a network. You're trying to weave a story of a request through multiple services or nodes. One of the more popular tools here has been around since 2012. It's called Zipkin. All right, let's go through each of those in more depth. So logs, again, it's mostly logging text about an event. Can be used for auditing purposes, where you're trying to collect evidence of something occurring. It's really good for troubleshooting if you need to see what happened during an event. You can look at the log data and help you diagnose the problem. So can be used to build monitoring systems around, and you can attempt to find, just general understanding of what's happening in the system. Usually by walking through the log, you can get a pretty good idea of what's going on inside a system. The definition: logs is a serialized report of details such as test activities and entity under test console logs. So that would be a test log, a recording of events that occurred within a system. These can be used to troubleshoot systems and provide insights how a system is behaving. This is also good for auditing. As I said, they emit logs every time a transfer is initialized, for example. Transfers can be listed to identify what happened, so the auditors can use that as part of their audit. There's modern logging has kind of evolved from the beginning. Does, generally speaking, log standards have improved over the years. So structured logs are computer readable with defined attributes, makes it easier for searching logs. Distributed logging combines logs from multiple programs, multiple points in a network or a distributed system. Log analysis tools can allow searches, counts, and sometimes correlate data from logs. You can generally expect from any log a timestamp when the event occurred, human readable message, a severity code or statement like an error, a warning, information only, debug information, and something about the configuration that was active at the time the event occurred. So you can adjust which log instructions are active as well. So you configure logs themselves typically in systems. The box below here shows an example of such a log. So there's a timestamp, a message, sync proxy rules completed, then maybe gives an elapsed time for how long it took to complete, some severity indication, in this case it's only information, and finally it's a configuration data. In this case it has to do with the Kubernetes pod. There's lots of other considerations regarding logs. When you've got a lot of logs, a lot of volume, you may have to adjust the volume because it can get a little bit noisy. You know, it's the old adage, if you have too much information, it's almost like not having enough. So you can tune the configuration of your logs, maybe debug only, or error or warn only when you're in production, or only in development. So you can usually make those adjustments if you need to control the volume. You can access logs usually with indexes, search engines. The Senna and Elasticsearch or Splunk are examples of tools that can help with that. You can index for access, so index logs for only, usually index or keep logs around actively for 30 to 180 days. Again, the volume of information can get a little much. That way you can at least quickly search the most recent logs. And also it's a good idea to archive the logs for longer term, so you can literally retain for years in less expensive offline storage that may be needed to go back and do some audit or some long deep dive and diagnostic on something. And generally speaking, that's useful for audits as well when you're doing audits, you know, less frequently perhaps. There are limitations. Application designers typically turn to logs for debugging purposes, finding the root cause. Every log is a separate item, and you know, so it may be difficult to correlate across multiple logs if an event is difficult to pinpoint. The begin and end processing times are separate files, so you're going to have to do something to correlate across files. It can be, you know, there's an example of a problem if you have a slow request. You know, the request may dive deep into the distributed system and may be difficult to figure out, you know, really what happened. Whereas the, you know, the slowness in the chain of events coming from, and you want to be able to, you know, build a story that the requests could be correlated across multiple services. Well, logs alone don't really do that. So you can't really tell why it's slow or find the first error message. Perhaps it'd be a little more difficult, but if you only have a series of logs. And we'll find out later that other pillars can help with these problems. So the next pillar is metrics. So the definition, you know, metrics is a class of terms relevant to measurements used to monitor the health of a product or service, or performance, I would say as well. So modern operations teams support many servers, and therefore you can, you know, you've got a lot of events. Metrics can aggregate the many events for some overall view. The little diagram on the right here doesn't really have a whole lot of information. It's just metrics can be collected from various parts of a system and then presented to people to see, you know, at a big picture view of what's going on. For an example tool, you know, there's a lot of different kinds of application performance monitoring tools, APM. Some people call them application performance management tools. Essentially, you've got a lot of applications, maybe sharing resources. APM tools give you feedback to determine how fast the code is and when it's consuming resources. So it's really focusing on, you know, performance changes and indications of that. Again, some baselines typically. This is an example, if you know, how just show you how metrics can kind of also get out of control, and you need to, you know, determine what's going on in a real world scenario. Metrics alone may not be enough. So just take an example. Let's say you have a single metric on, you know, one event. So that's one metric, not difficult, but let's say there are 50 endpoints and you want to look at all of those. So now you've got 50 you know, examples of metrics across the 50 endpoints. Response times could vary per endpoint, but again, it gets a little complex. And let's say every, instance is slow, there's one instance slower than the others, run 10 instances, for example, you can 500 metrics, so the response time is 500, but 50 times 10. Again, that's getting a little bit cloudy to figure out what's going on, and ultimately you may have different status for every instance that you're looking for. So now you got 2,500 metrics. It's really starting to get expensive and difficult to deal with. And maybe you only want to know, maybe only errors that are slowing you down. You wouldn't know from this. There's maybe multiple statuses per metric, and it would be difficult if all you have is metrics. You wouldn't really be able to pinpoint where the problem's coming from. Small changes in monitoring granularity can multiply the metric count, and costs can go up quickly. That was a statement I guess I made in one of my articles.